Okay, so hello again. So now we will move to a new part, which is part 5 and 6, which is a graphing the function. So how to find the graph of the function, which is from lesson of overview sketching. Okay, so let's see how we can find the graph of any function. We will talk about or we will solve equations for different functions, polynomials, rational function, if we have square root in the function. So we will see these questions. First of all, let's start if by question 1. Okay, now the questions required from us actually it's from question 1 to 10 and from 11 to 21. So starting by question 1. So over here, actually in this question, I want to find every little thing. Okay, so I'll start as usual, finding the domain. Okay, since it's a polynomial function, that means the domain is R. It's very important to find the domain all the time. Now, find the derivative, okay, which is f prime is equal to. Now, f prime 3x squared minus the derivative of 3x squared is 6x, then the derivative of 3x is 3. Now make the derivative equal to 0 as usual. Okay, so we need to find the coefficients or the solutions for this equation. You can directly put it in your calculator. So over here I will write menu, okay, then a, then polynomial, then from the second degree, right? So in here I have a 3 as a first coefficient, minus 6 the second one, and 3 the third one. So I have 1 only. Okay, so I have 1. Okay, so that's it. That's it. I have x equal to 1 as my solution. Okay, so let's go back to this. So x equals 1. Okay, so in here, is it included? Yes, it's included. So the critical number is x equal to 1. So let's do the first derivative test. So here it is the number line. Then I have 1. Then after that I'll substitute in the derivative value greater than 1 and value less than 1. You will find that this is increasing, which means this value is positive and the second value is positive. Be careful, you have to substitute in the derivative. Okay, so I will write increasing, okay, interval. It will be from minus infinity to 1 union with 1 to infinity. Okay, no decreasing intervals. In here I have a critical point at 1 and f of 1. So if you substitute the 1 over here, what is the value I will get? So in here directly I will go to the calculator and substitute the 1. And actually after substituting the 1 it will be 1 only. So just write the function and substitute the 1. Calc at 1. So and here you will get 1. You will substitute in the original one. Be careful. Okay, now finished with the first derivative test. Let's move to the second derivative. Okay, now for the second derivative, f double prime, this is equal to, this is 6x minus 6. Okay, let's make it equal to 0. That will give me, after moving the 6 over here and dividing by 6, it will give you x equal to 1. So now all I have to do is just do the second derivative. And here number line, and I have 1. Okay, now you have to substitute any value greater than 1 and any value less than 1. After substituting value greater than 1, let's say it's 2. 2 multiplied by 6, it's a 12. 12 minus 6, which is going to be positive. So this is positive. Less than, let's substitute the 0. 0 times 6, this is 0 minus 6, so this is negative. So this is concave down, and this is concave up. Okay, so I will write over here concave up from 1 to infinity and concave down from minus infinity to 1. Okay, so now in here I can write also inflection point at 1, because we have changing from concave up to concave down. So at 1 and f of 1, which is, we have already found this, which is 1. Okay, so we can substitute in the original function directly. Okay, now we have found the inflection point. Now, if you would like, and I think this is very necessary actually, which is finding the x-intercept and y-intercept. That will give you extra points. You can plot them in the graph. So x-intercept, which is at y equal to 0. Now, at y equal to 0, you can put that directly in the calculator as we did before, which is putting the same value. So over here, okay, so menu equation, okay, so polynomial. Now I will substitute in the original function, because I'm finding the x-intercept for the original function. Okay, so it's degree 3. So now I'll put the coefficients. This is 1, this is minus 3, this is plus 3, and the constant is 0. Now I'll find the solutions. This is complex, we don't need that. We don't need the second one. The third one is x equal to 3. So that's it, x equal to 3, is it? Or 0? 0, sorry. x3 is equal to 0, yes. So I have x-intercept. So it will be at x equal to 0 and the y is equal to 0. Now for the y-intercept, it's at x equal to 0. You can substitute that directly in here. So 0 plus 0 plus 0, so which is going to be 0 as well. So it will be also 0 and 0. So that's it. So I found all the points that I can find. So in here, after finding all of these points, okay, I can start graphing now. So before start graphing, I have something that will help you all the time once you find the graph of the function, if you are sketching the graph. So it's called the mixed number line. Now what is that mixed number line? You can graph a number line, okay? Now for this number line, okay, you will put all the critical numbers and all the so you'll put all the values in the first derivative number line test and the second derivative number line test. So I have only one, so I'll put the one. Okay, now after that you will put the values that you've got from the first derivative test. So I've got after the one positive and before the one positive, so I'll put positive over here and positive over here. Now, after that, you will put the concave up and concave down graphs from the second derivative test. So in here, before the one, I have concave down, and after the one, I have concave up. Okay. Now look at this. We have two types of concaving. This is concave up, and this is concave down. Let's divide this by half. So I'll choose this one. Now, if you have increasing, okay, and concave down, you will choose this part from the graph. If you have decreasing and concave down, you will choose this part of the graph. If you have decreasing and concave up, you will choose this part from the graph. If you have decreasing or increasing, sorry, decrease or increasing, yes, increasing and concave up, you will choose this. So again, I will write them. So this is in case if you have increasing and concave down. This is in case if you have decreasing, okay, and concave down. This is if you have decreasing and concave up. This is if you have increasing and concave up. This is going to make the graph very easy for you. So this is the mixed number line. Okay, so now from this part I have concave down and increasing. So in here we have two parts. This is increasing and concave down. So that's it. I will choose this part. Now after the one I have increasing and concave up. So this is going to be my part. Okay, so let's see how we can graph this. So again, I will start the graphing now. So let's choose, or let's just make this bigger a little bit. So that's it. Okay, okay, good. So in here we have the points. First of all, start by plotting the points. You have 1 and 1 and you have 0 and 0. Okay, so starting by these points, so I have 1 and 1. This is 1 and 1, and you have 0 and 0. Okay, now before the one you have this part, so I'll graph the same part exactly. So that's it. Okay, now after the one I have this part. Okay, this is my part. So go ahead, and after the one I got one. That's it. Okay, so this is my graph at the end. The one. That's it. If you would like to check that your solution is correct or not, you can go directly to this most, for example, and this is my function. That's it. It's the same graph exactly. That's it. So that's it. This is how we can solve the question if we have a polynomial function. Next, inshallah, we will see how to solve the question if we have a rational function. So see you then.